Hello, my name is Chase. Question 1, we have consider the graph f of x equals 2 to the x. This is an exponential problem, so the line we see here comes up, hits the point at 0, 1, and continues upward. This function in itself is alone with no transformations, and each of these functions are essentially the same exact function, the same line, except with reflection transformation. So the first one we have g of x equals 2 to the negative x. So the only thing that's changed is the exponent has now become negative. This means that we will flip this line over the y-axis. So instead of the line going up and to the right, it comes down from the right. Same thing, hits the point of 1, and the asymptote is x equals 0. Second problem, h of x equals negative 2 to the x. So again, the same thing, same type of line, except now we have negative 2, meaning that there's a reflection over the x-axis. So the line will, instead of going up and to the right, it goes down and to the right, again hitting the point 1. This time it'll be 0, negative 1. And lastly, we have negative 2 to the negative x. So this is both of these transformations combined. So we reflect over the x-axis and the y-axis. So what will that look like? Well, the original looks like this. If we flip it one way, it flips over the y-axis, and then the second way flips over the x-axis. So if we do both ways, it will come up here. And again, we'll hit 0, negative 1. That's question 1. Question 2. We evaluate e to the 3 minus 2x equals 4, and we're solving for x. So I already did some, but I'll run it back. I had a slip up in the last video. But essentially, if we're solving for x, we first have to evaluate how to get rid of the e. And to do that through logarithmics, we use the natural log of e to take it out and to get it out of there so we can solve for x. So we take the natural log of both of these functions on either side. So we have the natural log of e to the 3 minus 2x. And this in itself is its own formula. The natural log of e to the x will equal x. That is a formula. Equals natural log of 4, because whatever we do to one side, we have to do to the other side. And so now we're left with, because this equation will equal the x, now we have 3 minus 2x will equal the natural log of 4. We can algebraically solve by subtracting 3 from either side, as well as the negative on the 2 we can cancel out. And we now have 3 minus the natural log of 4 equals 2x. Again, just going to solve algebraically. And x, if we divide by 2 on either side, we'll now have x equals 3 minus the natural log of 4 over 2. Putting this is pretty much all we have here, but as for graphing, we need to put this into a calculator, and that will give us the result of 0.809. So if x equals 0.809, that would be a line on our graph just before the 1 at 0.8. So right about there, that would be our actual function. Now solving for y, because y equals 4, we have to show the point where y actually does equal 4, and we can see the point 0.809, 809, 4, and that is where they correspond. Technically, any y equals point is going to equal the same x point because it is a vertical line. Okay, question 3. We're going to let f of x equal e to the x plus 4 plus 1, and the objective here is to find the inverse function, so the f to the negative 1 of this line. So first we're going to plot our y equals x line, which is just a simple basic linear function. We're adding 1 for every point that we rise. Perfectly straight, perfectly linear. This is an exponential function. It is a type of logarithmic in which we have transformations on both the exponent, or the x's, as well as on the outside. So this is going to be a vertical transformation, and this is going to be a horizontal transformation. I already started on this line, but essentially our asymptote is going to be y equals 1. It would just be 0, but we have this vertical addition of 1, so now our asymptote is 1. We're going to start here, and because we're shifting, this plus actually means that we're going to be shifting to the left 4. So we'll roughly about here start rising into our exponential function, and this eventually will cross over, I believe, at about, I believe at y equals like 55 something, but obviously I don't have enough room for that. So this is what our e to the x plus 4 plus 1 function looks like originally. Now to find the inverse of this, essentially we have to solve for y and then solve for x again. It's because we're reversing the whole equation to look for what we need. So to start, here we're going to flip the x and the y. F of x is just y. So we're going to flip that. Now we have x equals e to the y plus 4 plus 1. And now we're going to be solving for the y in order to get it back to its original state. It'll just be inversed. So to do that, we are going to subtract 1 from each side. So now we're going to have e to the y plus 4 equals x minus 1. This is going to translate down as we did before. we see that we're going to need the natural log to take out this e function, because the ln of e is going to give us our regular log of 1. So we're going to take the ln of both of these functions. So what we do to one side, we have to do to the other. Take the e to the y plus 4 equals the natural log of x minus 1. Yeah, and then as we said before, this function here, is fitting into the formula of ln to the e of x is going to equal that x. So essentially all this is equals y plus 4. So now we have y plus 4 is equal to the natural log of x minus 1. Now we just have to solve for y again. Very simple algebraically. We just have to subtract 4 from both sides, and we get y equals the natural log of x minus 1 minus 4. And this is our inverse function. This is the f of negative 1 to the x. That's all this inverse function now is. So how do we graph this? Well, because it's just an inverse, we flip it directly over the y equals x line. We see that we have a vertical shift of down 4, and we have a horizontal shift of plus 1, or to the right 1. This is going to be negative 1, but that's going to mean we shift to the right. And so that will be about right here. Our asymptote is going to be 1, 0. And our actual line come along this line, and it'll stop roughly here, and it will continue upward until it hits, again, I think it will be 55, 0. I think it's 55.50 specifically, but obviously I don't have enough room for that. So we can see that these are inverse functions. They're the same line flipped over the y equals x line. And the reason they do this is because logarithmic functions, or just to simply explain why logarithmic functions do this in comparison to simple exponential functions, is log functions, if you were to have an exponential function of xy, point xy, what a log does is it takes that and just flips it completely. We'll have the yx now. And that's all you're seeing here. This is the exponential, and this is the logarithmic. And they go hand in hand in that way. Okay, question 4. We have this final equation, f of x equals negative 3 times the natural log of x minus 2. And our objectives here are to identify the domain, vertical asymptote, and intercepts of it, and essentially describe its transformations from the natural log of x. So first, I think we should note the natural log of x. So y equals natural log of x is just going to be a natural logarithmic function in which it approaches the asymptote of y equals 0 and intercepts at x equals 1, and it continues on that way. That would be y equals ln of x. So what makes this any different? Well, it has transformations, and transformations are essentially just anything included in the equation that will vertically stretch or compress. It will flip over axes. It will shift the actual line back and forth. So in this case, if we start, or actually let's start here with identifying the domain. So actually, yeah, we'll graph it first. So we can graph it by using this line here, and all we have to do is note that negative 3. So what does negative 3 mean? Negative 3 essentially means that we are going to be stretching it by 3, by a factor of 3. So instead of hitting the 1, 0 point, it's actually going to hit the 3, 0 point. So this is where it will actually intercept. Negative, meaning we flip it completely over the x-axis because it's outside of the x equation. If it was inside, we would be flipping it over the y-axis. It's outside, flip it over the x-axis. So this will essentially be an upside down line. Instead of going this way, it will come down and do this motion. Finally, the final transformation that we see here is that it is x minus 2. Because it's inside of this x, it's not going to the left as you would think it's minus. It's actually being shifted to the right, horizontally. So if we take all that into consideration, it is going to start here. The asymptote is going to be here on this line because it has been shifted 2 to the right. The asymptote is no longer 0. The asymptote is now 2. Start here, and it is going to hit our 3, 0 point and continue. And you can see that it somewhat mirrors this y equals ln x point, but it has been transformed in varieties of ways. So this is now y equals negative 3 natural log of x minus 2. So that is the difference between the two. Again, just to recap our transformations that we made here, we have a negative in front in the coefficient of the natural log, meaning it's going to be flipped over the x-axis. It has been stretched by 3. It's been stretched vertically by 3. So it's been made wider, and it has shifted the actual point of divergence along the x-intercept that's not true. But that's not true. It's just been expanded more, so it'll have a wider range of curvature by a factor of 3 as compared to the natural log of x. And finally, it has been horizontally shifted to the right by a factor of 2. So instead of the asymptote being x equals 0, it's now x equals 2. And the last couple things we do here, we identify the domain, vertical asymptote, and intercepts of our transformed function. So domain, we can see going from left to right, it starts here at x equals 2. So we have a parentheses of 2, and it goes on and on and on to infinity. So this is our domain. It wouldn't be a bracketed 2 because that would imply it actually hits 2. Because it's an asymptote, it always comes closer and closer and closer, but it never hits 2. So this is our domain. The vertical asymptote, as we just described, is x equals 2 because it's been shifted to the right. So that's this line here. Vert asym is x equals 2. And the intercepts, finally. So it's just the same log function. It's just been shifted to the right a couple, so it's just 1 away from our vertical asymptote. So our intercept, our only intercept is going to be the x-intercept of x equals 3. Okay, and finally, last thing, in comparison to the regular exponential function, I drew this line here. This line here represents a regular exponential function. Again, we can see that the natural log function flips the x and y of the exponential and turns it to yx. And that is what we see here with this natural log. Of course, our final product with all of our transformations included looks nothing like that. But that just goes to, that's just including the transformations. Without it, the logarithmic is an inverse of our exponential. Thank you.